That, my friends, was called the Gloucester Cheese Rolling Race. It happens in England every year in Gloucester. They roll a huge wheel of cheese down a steep slope, and the first one to reach the bottom gets the cheese. So as you can tell, they have a nice muddy hill, and the slope is obviously very steep. They would have a little bit easier with a lower level slope. So we're still on slope. Slope is a huge concept for us. Incorporates so many different things, as to the slope of that hill. In the beginning, we showed the slope of different gradients on those signs, and then we also look at it in a linear perspective too. And so we're going to focus that on today. Slope, as we said before, is the rise and run of a slope or a hill or a mountain or a line. But the thing is, in order for it to have a slope, it has to be at a constant rate. So it has to rise and run the same amount every single time. So if we were to draw a line here, this is a linear equation because the rise and run is the same throughout the entire line. Okay, it rises and runs the same amount. So in order for something to have a slope, it has to have a constant rate, which means we said before that slope is the rise, and we can say fall too if it's a negative line, the rise over the run. And we mentioned that the rise is the y, the change in y, and the run is the horizontal or the change in x. So we can use this concept of slope to determine if something is a linear relationship, okay? So if we look over here, let's start with this basic one. We have our x and we have our y. So we want to look at the change in the x and then the change in the y. So if I look from here to here, there's a change of 3. If I look from here to here, there's a change of 3, okay? I'm not going to look from here to here because I really need, if we're looking at changes of 3, I need the coordinate for if it was 3 more, which would be 6. So we're going to look at just these two. So if I look from here to here, the change from 0 to -1 has a change of 1. And the change from 0 to 1 also has a change in 1. So we can say the rise is the same as the run. So this we will say is a linear equation because it has a slope. Its slope is 3 rise over 1. So it's going to rise 3 and run 1 the entire length of the graph. Let's look at this example down here as well. We want to be able to determine if this is a linear equation or not. Here's my x coordinates and here's my y coordinates. Remember, the y is your rise or your up and down, and the x is your run or your horizontal. Okay, so we're looking to see, is there a consistent change in the y's to the x's? Okay, so the first thing I look down and I make sure that these are changing the same amount each time. So there's if we look from here to here, there's a difference of 1. From here to here, there's a difference of 1. From here to here, there's a difference of 1. And from here to here, there's a difference of 1. So it's not jumping coordinates, right? So if I look from here to here, I can say the change between 0 and -2 is 2. There's 2 spaces between 0 and -2. Same thing for here. The change between 0 and 2, again, is 2. The change here from here to here is 2. So if I wanted to do the slope, and from here to here is 2. So if I wanted to identify the slope, the change in y is 2 to the change in x, which is 1. So it has a slope of 2 over 1. Or it will rise 2 and run 1 consistently through the entire length. So therefore, we can call again this a linear equation. It's a linear function. If it has a slope, it's a linear function. All linear functions have to have the same rise and run. If it varies, it's not one. So if we go back and look at a linear line, we're saying that the rise and the run is the same. So if I rise 2 and run 3, rise 2 and run 3, I will always find a point on this graph, and it increases at that same rate throughout the entire length of the line. I'm supposed to be able to click on that. Do something. Oh, there it goes. So here we go, the rise 2 and run 3, okay? And that goes for a line, but you can make those into word problems, you know. That's 2/3, which is 67%. So you can take it something that's rising at 67% each time, okay? Or think of a proportion that is going up 2 and then walking 2, okay? Up 2 stairs, walk 3 steps, up 2 stairs, walk 3 steps, something like that. And that tells you the steepness of the line. And then again, we need to know that this is negative because it's going down. And that's why I dislike that rise over run, because this one actually falls and runs, right? Falls 2, runs 3, falls 2, runs 3. We can also say this backwards. We can say it rises 2 and goes to left 3, and the left direction is negative. So really it doesn't matter which way you do it. You can say I rise 2 and I move negative 3. So that would be 2 over negative 3, which gives you negative 2/3. Or you can say down 2, which is negative 2. And then right 3, which is the positive direction here. So then that'd be negative 2 over 3. Either way, it's still negative 2/3. So it doesn't really matter whether you choose to rise or run, but you have to pay attention whether you're going to the negative or to the positive direction. Okay. So I want you to take the last minute and find the slope of these two lines and write that down. And then tomorrow we will do a little bit more with different steepnesses of slopes. Good night.